nessas putinhas safadas.
Car completely defying gravity. But is that just a cool myth that engineers tell each other? Or is there some real hard physics that backs it up? Well, that's exactly what we're going to figure out. All right, so let's meet the star of our show, the incredible Porsche 956. This machine came out in 1982 to compete in Group C racing. Now, the big thing about Group C was that the rules limited how much fuel you could use. So raw horsepower wasn't the only answer. Designers had to get creative, and they started looking at the air itself as a way to get faster. So how in the world do you get a car to stick to a ceiling? You can't just use superglue, obviously. You have to use physics. And the secret isn't about pushing down on the car. It's actually about sucking it up from underneath. That sucking force has a name. It's called downforce. And the easiest way to get your head around it is to think about an airplane wing. A wing creates lift because air goes faster over its curved top, right? Well, a race car is designed to do the exact opposite. It's basically a whole body, upside-down wing that creates a low-pressure zone underneath the car, gluing it to the road. And the Porsche 956 was an absolute master of this, using something called ground effect. Here's how it works. First, the car grabs a bunch of air and shoves it into these huge tunnels under its body. Then, and this is the clever part, those tunnels get squeezed in the middle. This makes the air speed up like crazy. And basic physics tells us that fast-moving air equals low pressure. The result? A massive vacuum that literally sucks the car onto the surface. Okay, so the theory sounds pretty solid. But hey, talk is cheap, right? Can we actually prove this with cold, hard math? That's what we're about to do. We're going to put the numbers to the test and see if this whole legend really holds up. So it all boils down to a simple tug-of-war between two forces. In one corner, you've got gravity, the car's actual physical weight, trying to pull it off the ceiling. And in the other corner, you have downforce, that aerodynamic suction, trying to pull it onto the ceiling. For this to work, downforce just has to pull harder than gravity. Simple as that. First things first, we need to know the strength of team gravity. And for that, we need the car's mass. The official spec sheet for the Porsche 956 says it has a mass of 820 kilograms. So that's our starting point. But here's the thing. Mass isn't a force. To get the actual force of gravity, its weight, we have to do a quick conversion. And when we do that, we get our magic number, 8,040 newtons. That is the number to beat. Our downforce has to be bigger than that. So, how do we calculate downforce? We use this equation. Now, don't worry, don't let the symbols scare you. All this really says is that the amount of downforce you get depends on a few things: how thick the air is, how aerodynamically efficient the car is, and, this is the big one, the car's speed squared. So, let's plug in our numbers. We know the density of air, we know the specific aero efficiency of the 956, and most importantly, we have the speed we're testing at, a blistering 321.4 kilometers per hour. That's just a hair under 200 miles per hour. All right, the stage is set. We know we need to beat 8,040 newtons. We have our formula, we have our speed. It's time to run the calculation and find out once and for all, is this story for real? And there it is. The answer is a staggering 22,306 newtons of downforce. Just let that number sink in. That's not just a little more than the 8,000 we needed to beat. It completely and utterly demolishes it. And this chart just shows you how insane that difference is. See that bar on the left? That's the car's weight pulling it down. And that giant bar on the right? That's the downforce sucking it up. It's not even a close fight. It's a total knockout. In fact, the downforce is almost 3 times greater than the car's own weight. So from a purely mathematical, purely aerodynamic point of view, the answer is a massive yes. The legend is true. Theoretically, the Porsche 956 could drive upside down. But wait a second. If the math works, why have we never seen this happen? Why isn't there some viral video of a Porsche driving at a tunnel upside down? Well, this is where a beautiful theory slams headfirst into a messy little thing called reality. And that's the million-dollar question, isn't it? If the physics are sound, what's the holdup? Well, the problem is that a car isn't just an aerodynamic shape. It's a complex machine filled with fluids, pumps, and all sorts of bits that were designed to work in one direction, right side up. And here are the 3 big deal breakers. First, engine oil. It sits in a pan at the bottom of the engine, right? Flip the car over, and suddenly the oil pump is just sucking air. The engine would seize up in seconds. Game over. Same thing with fuel and coolant. Their pumps would suck air, and the engine would stall and overheat. And maybe the biggest problem of all? That amazing ground effect is incredibly fragile. The tiniest bump on the ceiling would break that beautiful aerodynamic seal, and all 22,000 newtons of downforce would vanish instantly. And you can imagine what happens next. This quote really just nails it. The car's shape is a work of genius. It's brilliant. But all the car's guts, the engine, the pumps, the fluids, they all rely on gravity to do their job. They were never designed to work against it.
And that's really the punchline to this whole story. The legend is fascinating because it's kind of true and false at the same time. The aerodynamics say yes, absolutely, but the mechanical reality says not a chance. It's a brilliant theory hitting a very, very practical roadblock.